Greetings, math fans. All right, so this is chapter 4 of Trig, and what we're going to be doing here is graphing circular functions. Okay, this is my favorite chapter because I love the graphing part, and I can guarantee you that when you're done with this chapter, you're going to wish we could do this chapter again. Okay, because it's a really, really good chapter. And I know sometimes people panic, are like, oh my gosh, it's a graphing chapter, it's brutal. This is a great chapter. So, first of all, we say the word circular functions because this is what we did in the last chapter, is everything is going to be terms of our arc length, or everything's going to be terms of pi. That's really important. We're not going to do anything with degrees. We're going to always be dealing with pi. All right, so let's start out with a friendly little function, which is kind of a main thing here, y equals sine of x. All right, and first of all, I want to tell you this is a periodic function. We've actually talked about sine of x a little bit, but what a periodic function means is the values repeat over a specific period. Okay, the values repeat over a specific period. So basically, just to kind of give you a real life example, the cost of a convertible. Okay, if you go to buy a convertible, if you buy a convertible in the summer, the cost increases in the summer because they always want you to buy, you always want to buy a nice convertible with this top down and enjoy the nice air when it's warm out, of course. So the cost is going to be high. And the cost goes down in the winter. Because, they may have a couple convertibles in the lot, but who's going to want a convertible when it's, 20 below out? So that's why you can get a good deal. It's a little bit cheaper. So what happens is, the reason it's periodic is because it goes up in the summer, down in the winter. And the summer and the winter, comes and goes, right? So that's why it's periodic. Here, another example is even just if I talk about seasons, right? The temperature, it increases in the summer and it decreases in the winter. But it goes back and forth. Summer's up, winter's back down. Summer up, winter back down. All right, so that's what I mean by a periodic function. All right, so let's actually talk about graphing graphing some of these, or graphing y equals sine of x. I didn't really talk too much about that yet. All right, circular functions. Let's draw the unit circle here. And do you guys agree? Well, first of all, this is 0. This is pi over 2. This is pi. This is 3 pi over 2. And this is back to 2 pi. So we're going to have one period of our function is going to be between 0 and 2 pi. That's going to be one period. All right, so let's just get a couple of values here. You guys are going to have a worksheet to work on to actually make it much more detailed. But if I said y is equal to the sine of 0, which equals 0. Okay, so that's the first. So it's 0, and this is of course radians, and that is what the value of y is. So that's like your x value. Okay, so we're going to have y equals sine of pi over 2, and that's going to be 1. We have y equals sine of pi back to 0. Y equals sine of 3 pi over 2. That's -1, and y equals sine of 2 pi. That's just back to this guy right here, and that's back to 0. So it fluctuates between 0, 1, 0, -1, and 0. All right, so if I make a sketch of this, here's 1, and here's -1. All right, so let's put our values here for radians. This is pi over 2. This is pi. This is 3 pi over 2. And this is 2 pi. Okay? And let's plot these points now. So at 0 radians, you're going to have, it's going to be at 0. And then at 1, it's going to be up here. And then at pi, or sorry, I should say at pi over 2, it's going to be at 1. At pi, it's at 0. 3 pi over 2 is negative 1. And 2 pi is back at 0. All right? So, again, you guys are going to plot a lot more points in here to actually see that it is a curve. Now, I am going to work on you guys drawing these sine graphs and cosine graphs and all the trig functions, and you guys are going to do a good job with drawing them. Okay? I do not want to see sloppy drawing here. I want to see good drawing. So, what I'm going to do is when I'm going to draw this guy, this is really curve. So it's curve. So this is kind of how you do it. That's a little bumpy, but okay. You have one curve. You take your pencil off the paper, and then you have another curve going the other way. Oops, that was a little messed up here, like that. Okay, and that's what your graph looks like. That's one period of the graph. Now, of course, this graph actually keeps going, right? That's another period, but it keeps going and it goes the other way too. That's why it's a periodic function. It keeps repeating. So from this point to this point, it repeats again, and going backwards, it repeats. So that's what a periodic function is. Okay, it repeats. Now let's talk real quickly here. Let's talk about our domain and range. So this is for y equals sine of x. Okay, well, domain, isn't that x values? And what are x values? Well, isn't it like the pi over 2, pi over 2, pi, 3 pi over 2, 2 pi? So doesn't just keep going? So it's from negative infinity. Oops, this actually should be a parenthesis. You guys remember that? It means it doesn't include it, to infinity. That's the domain. And what's the range? The range are y values. Well, what is the maximum y value for just this guy here? Isn't it between negative 1 and positive 1? It's including those values, so it's between negative 1 and 1. Okay, very important. That's y equals sine of x. And again, on your worksheet, you're plotting a whole bunch of points, but we're going to actually be plotting 5 points every time. And in our next lesson, we talk about amplitude. Then I'm going to actually get into a few more problems, and I'm going to show you how easy it is to graph these. Okay. And if you notice, the period for this is 2 pi, because this is where it starts right here and ends right here. In between 0 and 2 pi, the period is 2 pi. It's like the period of a year is 365 days, because you keep repeating. Okay, 365 days later, you get another winter, and you get another 365 days again, you get another winter, etc. And so that's what the period is for y equals sine of x. It's 2 pi. All right. Couple things I want to point out here, and I'm going to use the highlighter. I want you guys to understand that sine starts at 0. Okay, and it actually starts. Let me redraw this because I really want to make a couple points here. Okay, so pi over 2, pi, 3 pi over 2, and 2 pi. And we have 1 and negative 1. Okay, and if I plot my points like I did before, there, and there. Okay, so you curve up like this, take your pencil off, and back around like that. All right, so I want to talk about a couple things. Really, the main thing here is where sine starts. Okay, at the start of the period, it always starts at, I'm going to put this in quotes, it starts on the x-axis. Okay, I'm going to put that in quotes because sometimes it's going to shift up and it's going to shift down. Okay, we're going to draw another x-axis, but that's where it starts. It starts on the x-axis. Okay, and it can go down or it can go up. It depends on, we'll talk about that for the next lesson. But it starts on the x-axis. Okay, so let's do our next one, y equals cosine of x. So let's do our little unit circle here again. So this is 0, pi over 2, pi, 3 pi over 2, and back to 2 pi. All right, and so if it's y is equal to cosine of 0, that's equal to 1. Y equals cosine of pi over 2, that's equal to 0. Y equals cosine of pi, it's -1, and y equals cosine of 3 pi over 2, it's equal to 0, and back to 2 pi right here, 2 pi, and that's equal to 1. All right, so if I graph this thing, so pi over 2, pi, 3 pi over 2, and 2 pi. So it's a 1 and a -1. All right, now, so at 0 radians, it starts at 1. So let's put a point right here. So it's a little bit different than sine. And then it goes to 0, then it goes to -1, and then it goes back to 0, and it goes to +1. Now, this is so tempting. In fact, I'm going to draw it wrong first. It is so tempting to do this, to go like this. Okay? You are going to lose a point for that, because that is a really sloppy graph. In fact, that's an absolute value graph. All right? And that's just a really bad graph. So let's get rid of that guy. And this is what I really want to see here. Okay, it's going to curve down like this. Take your pencil off the paper, and then it's going to curve up like this. Take your pencil off the paper, and then it's going to curve back around like that. Okay, it's got to look like that. You got to see those curves in order to get full credit for that. Because again, if you're sloppy, you're not going to get credit. And the first way I did it, just where it looked like this and this, okay, I call that a CMS. That's called for caveman style. Okay, so no CMSs, don't do caveman. Caveman is where they grab the pen in one hand and go, all right, and then you draw like a nice V shape. It's like, boo, that's caveman style. You can't do that. You got to draw a nice curve. Okay, that's what I want to see. All right, and let's make a couple points of this. First of all, the domain and the range. What's the domain? Well, isn't the domain, again, doesn't it just keep going, and doesn't this keep going? So isn't the domain all real numbers again? So it's from -infinity to infinity. That's the domain. And what's the range? Well, isn't it the same thing? Isn't it go from -1 to 1? Okay, so the domain and the range of cosine and sine are actually the same. Okay, that's not too bad. So let's, one thing I want to point out here, math fans, is that cosine starts at the maximum point or the minimum point. So in other words, here it starts here. It could also start at -1. It all depends on if it's positive or negative, which we'll talk about for the next lesson. All right, so that's what cosine is. It starts at a maximum or minimum, as opposed to sine always starts at the, in quotes, x-axis. All right. So that's pretty much it for actually graphing these. The one thing I want to also mention is on your graphing calculator. It's really easy. You just you go to, make sure your calculator, it's got to be in radian mode though. It's got to be in radian mode. If it's not in radian mode, it's brutal. Okay, it totally gives you a wrong answer when you're graphing something. And if you would happen to try it in the wrong mode, it would not give you a good answer here. Okay, so it's got to be in radian mode. So it's so easy. You just type in y equals, you hit y equals sine of x. That's all you do, and then you hit graph. Actually, this is always a handy feature. You hit zoom trig, and then it puts it in the proper mode. for graphing. Okay, that's pretty easy when you're doing these graphs. All right, so anyway, that's it for day one here, math fans, and that is just basically doing the basic graphs for y equals sine of x and y equals cosine of x. And then we're going to do things where it's a lot taller and steeper and wider, and shifts to the left and shift to the right and shift up and shift down. So there's actually quite a bit of stuff to do with all these graphs. All right, that's it, math fans. Have a great day. Goodbye.